Okay. Hi. So I'll be explaining task 4, exploring partial mode extraction in language model. So first I will be explaining the general idea behind it. So we are exploring the vulnerability of the production language model by making API queries, and we extract like how much information users can extract via the APIs via API queries, and um, the paper has some assumptions for different categories, different API categories. So the first one is only theoretical, where we have access to complete logic vector that feeds into the softmax function for every vocabulary to prove a theory. Well, it's not realistic in the in the in actual production model because we don't have access to the model weights. But it's a good way to prove that the theory in the paper works. So that is what we'll be focusing on. And I will be explaining a bit on the related sections. So section 4, extraction attack logic vector APIs. So we are recovering the hidden dimensionality and the embedding projection matrix. But for this task, we only focus on recovering the hidden dimensionality, and they provide us an algorithm to extract it. And my code is based on that algorithm. So we have an query n random prompt, and we query it, and then we collect the logic vectors into a metric queue, and we use SVD to compute the singular value queue, and we identify the cliff. In our case, is 2048 queries, and a large singular value is the hidden dimension. And yeah, so in this experiment, they're using the PCR 1.4b model. So the exact hidden dimension is the green line, and if the number of queries is less than 2048, then all single values appear to be significant. But if it's larger, then additional queries don't produce any significant values, and it only produces output that are linear combination to what it already been seen. And here's my implementation. I'll be using the exact model as a paper, and we can see that our result is very similar. We have different magnitude, but I think different magnitude doesn't really affect like the success of the reproduction of the reproduce. It's just that I think the difference is because they have maybe different prompts, or they normalize the magnitude in some way. But anyway, we show that there's a cliff on the cliff at 2048, and which reveals the hidden dimension of the model, and less if the query less than it, so it's terminated because the query is hidden, then the query is less than the hidden dimension. But if we have query larger than 2048, then after the hidden dimension or 2048, then the value is significantly smaller by 100 times. Now I will talk a bit about investigating the method failures or the security gap. So in the theoretical proof, for all of their models, there has been success. They succeed in finding the hidden dimension, but except for GPT-2. So GPT-2 it has 268 hidden neurons, but only 757 are activated in practice. So if we use like a lower lower pre precision like 16, then only 757 are activated. But if we use a higher precision like 64, then all of the hidden neurons will be activated. So if we look at this graph right here, because we're using float 16 precision, then only 757 are activated. But if we use a higher precision like 64, then all of the hidden neurons are activated, and this aligns with the paper's findings as well. So yeah, it's aligned with the paper, and I think that's about it. That's the theoretical implementation of the paper.